Welcome to the lecture of production of automotive components. This lecture will be basically dealing with injection molding of instrument panel. So as you can see in the picture on the left hand side, you can see the instrument panel where you have all the readings of your speedometer, the engine RPM, the display which you have mentioning the navigation and other details. So that is basically your instrument panel. So on the right you can see the dashboard making production system, that is a video. So if you just click on this link, it will just play the video. So I'll attach this as a presentation as well, so you can go through this like YouTube video which I've attached to the link later. So I'll post it in the presentation. So you open the presentation and click on this, you'll be able to see the video. So next we'll talk about the injection molding of instrument panel. So I told you what is an instrument panel. So if you see, it is basically made up of plastic material. So whenever you have plastic, the process which we use for the polymer fabrication is injection molding, and it basically evolved from metal die casting. But here the polymer basically has a very high viscosity and you cannot easily pour it to a mold. So you need a large force to inject this polymer into the mold. So, and what happens is not just like the usual quantity of material that you have to pour into a mold to make a casting, but here you need to pour more, which means more of the melt of the polymer material has to be poured, because during solidification there will be a lot of shrinkage because the material is a polymer, so it will shrink more. So you need to pour more to make sure that it occupies that exact size of the mold. And basically what happens here is you'll be having plastic pellets. You can just imagine it as like small stones. Like these kind of materials will be melted and poured into the mold, and then it will take the shape of the mold, right? So it can either be a pellet or it can be also a powder resin. So when this is subjected to high force, when it is forced into the mold under high pressure, you will be having the parts produced. So that is how the instrument panel is made. So next, talking about the injection molding machine, it's mostly hydraulically powered inline screw machines. Nowadays even the electrical motor driven machines are made, and you have three main units. One is a clamping unit, plasticizing unit, and the drive unit. So clamping unit, as the name suggests, it is basically to hold the mold. It can close, open, and the main components, you have fixed components and you also have the moving plates which basically help in opening and closing of the mold. Second is your plasticizing unit or the injection unit. What it does is it melts the plastic and then it injects it into the mold. And drive unit basically provides the power to the first two units. And how the injection molding machines are classified is according to the clamping force. Like that is a force that pushes the two mold halves together to avoid opening of the mold due to internal pressure of the plastic melt in the mold. So when you pour this plastic into the mold, what will happen is it will induct a force that is opposite to the clamping force, right? So clamping force is very important, based on which the injection molding machines are classified. It can range from 200 kilonewton to 100,000 kilonewton. So here is a picture of the injection molding machine. Here you can see basically so here you can see the mold, and then you also have a clamp over here that produces the clamping force. Here is the cavity, and this thing is the nozzle through which the plastic melt is induced into it. And this whole thing is your plasticizing unit, because here what will happen is once you pour these plastic pellets through the hopper, it goes through this. You have heaters, so these heaters will basically melt the plastic, and on this side you can see a motor or drive, which is nothing but the motor unit. So these are the three main units which you have in the injection molding machine. On the right you can see how that machine actually looks like in the industry. So you have three main stages in each of the injection molding cycle. One is injection, second stage is holding pressure and plasticating, and third is ejection of the molded part. So when this stage 3 is completed, the mold will close again and the cycle will start over again. So it's a cyclic process. So first stage, which is injection of the plastic melts, into the mold. So what happens here is the mold will be closed and nozzle of the extruder is pushed against the sprue bushing of the mold, which means here the mold is initially closed, right? So what will happen is the plastic melts are basically injected into the mold. So there will be a screw which will basically push this to make sure that it is being injected, right? The second will be holding pressure and plasticating. So when this mold is completely filled, so when the injection process is over, then what will happen is the screw which basically pushes this will remain on hold, which is called the hold time. So during the hold time, what will happen is some more melt will be introduced into this, so that whenever there is some contraction or shrinkage, that can be compensated. And then what will happen is the gate, which is the entrance into the mold, will freeze. So at this point, then the mold will be isolated from the injection unit, right? So then what will happen, the mold will be subjected to a very high pressure, the clamping force will be induced, and as the melt cools and solidifies, we have to make sure the pressure is high enough to avoid seam marks but low enough to allow easy removal of the part. So this is called the pressure is holding pressure and plasticating, letting the mold to cool. And the again, what will happen after this plastication stage, the material is pushed forward from the feed hopper through the barrel and towards the nozzle by a rotating screw. So this period of screw rotation is called screw recovery. So what will happen during this rotation of screw is it will push the plastic from this hopper, like the nozzle kind of structure which you saw on top. So from the hopper it is being pushed and then the plastic is moved forward, right? So then when it moves forward, you have the electric heater which will basically heat and then the plastic will be melted, right? So that is what happens in this process. So the plastic will be melted in the center because of the heater, and the rate can be controlled by what is called the screw back pressure, that is hydraulic pressure exerted on the screw. Based on this pressure, you can control what will be the rate at which the plastic melts. And then when sufficient melt gets accumulated in front of the screw, the rotation of the screw will stop, and then you have what is called the soak time. Screw will remain stationary for some period until cooling is completed. This period is often called as soak time. So you have two different times, so just remember the difference between hold time and soak time. So then additional plastic will melt in the extruder from conductive heating, and then the melted material will make sure that there is thermal uniformity around, and you can also make sure that the soak time is short to improve thermal homogeneity significantly. So next, the last stage is ejection. When the material has cooled sufficiently to retain its shape, then the mold will actually open and the parts are ejected from the mold. So when the molded part has been ejected, the mold closes and the cycle will start all over again. So third is just the ejection process. So all this can be illustrated with the help of a diagram, which is injection molding cycle time. So this is on the horizontal x-axis, you can say, with respect to time. So the first row over here talks about the position of the screw. The screw is pushed forward, whether there is hold time, screw recovery, dwell time. So these are the times wherein the screw that is basically present in your plasticating unit makes sure that the plastic pellets go forward or they are on hold, or the screw comes back again. So that is this. Second talks about the mold, whether the mold is getting filled and there is cooling and then the part is being ejected. And finally you talk about whether the mold is closed or whether the mold is open. So the different stages can be illustrated in the figure shown below. Top bar talks about the movement of the extruder screw. Second bar, action going on inside the mold, and third will talk about whether mold is open or closed. Major part in this is the cooling time required for the plastic that will reduce the temperature to which the part can be removed without significant distortion, because if the part is still hot in the mold and then you remove it, there's a possibility of that dimensions getting distorted. So important point here is the main variable that determines the cooling time is the thickness of the molded part. So thickness of the molded part plays a very major role in making sure that how much cooling time is needed for every component. So this is the overall process of making instrument panel. Thank you.